Find the real zeros of f of x equals x to the fourth plus x to the third. All right, and then when we're done, we need to find the multiplicity of some of those. Okay, so we got a graph here, but the graph doesn't do it a whole lot of justice. The zeros is when my graph crosses the x-axis, and it looks like that happens at 0 and -1, but who knows? So what you do algebraically is you just set this equal to 0. And what I'm going to first do is factor out x to the third, which leaves me with an x plus 1. Now, whenever you have two or more things multiplied together equal to 0, you use what's called the zero product property, and you set each part equal to 0. So x to the third equals 0 and x plus 1 equals 0. Those are my two different things. In order to get x all by itself, I cube root everything. And believe it or not, 0 times 0 times 0 is 0. So the cube root of 0 is 0. So that's one of my potential answers. This guy's a bit friendlier, maybe. Subtract 1 from both sides, and you have x equals -1. So those are my real zeros, x equals 0 and -1. What does multiplicity mean? Well, if this is x to the fourth, technically I should have 4 answers. And technically I do. It's just since that I pulled out an x cubed, 0 repeats itself. So x equals 0 has a multiplicity of 3. It's a triple root. The other one has a multiplicity of 1. So if I wanted to say x equals -1 multiplicity 1, there you go. But I have essentially 4 answers, 0, 0, 0, and -1. And this is 3 zeros because it's x to the cubed equals 0. So that's what multiplicity means. Not to be confused with felicity, a show from the 90s. Divide using long division. I love polynomial long division. So when you do polynomial long division, your factor go there. And what go here is this guy. Oh, but be very careful. X to the fifth, x to the third. I'm missing something. So as I write this in, anything that's in between that's missing is filled in with a 0. So in this case, 0x to the fourth. Minus 15x to the third, minus 9x squared, plus 11x, plus 12. This is going to be a good one. All right. Treat this like regular long division. You start out with the first part and the first part, and you find out how many times or what times x gives me 2x to the fifth. Well, 2x to the fourth times x gives me 2x to the fifth. What I do is I take this guy right here, my quotient, and I multiply it to my factor. 2x to the fourth times x is 2x to the fifth. That will always happen that these guys are exactly the same, otherwise you did it wrong. However, this is going to be different. 2x to the fourth times 2 is 4x to the fourth. Just like long division, you subtract this guy underneath, but when you subtract this whole thing. So you become a minus and you become a minus. This crosses out. 0x to the fourth minus 4x to the fourth is negative 4x to the fourth. All right. Now we drop down the next guy, negative 15x to the third, and we repeat. Okay. X times what gives me negative 4x to the fourth? X times negative 4x cubed gives me negative 4x to the fourth. Now take this, multiply it to the entire factor, and write it underneath. Negative 4x cubed times x is negative 4x to the fourth. Negative 4x cubed times positive 2 is negative 8x to the third. Subtract this entire factor, which means flip the signs for both. This will always cross out. Negative 15x to the third plus 8x to the third is negative 7x to the third. Drop down this guy. Repeat. Okay, and we're still moving. We're like halfway done. X times what is negative 7x to the third? Negative 7x squared times x is negative 7x to the third. So take negative 7x squared times this whole factor, write it underneath. Negative 7 times, negative 7x squared, times x is negative 7x to the third. Negative 7x squared times positive 2 is negative 14x squared. Subtract this entire product, so that makes these signs switch. Negative 9x squared plus 14x squared is 5x squared. Drop down the 11x. X times what is 5x squared? X times 5x is 5x squared. Take that 5x, multiply it to the entire factor, and write it underneath. 5x times x is 5x squared. 5x times 2 is 10x. Subtract this entire product, which makes you a minus sign. This crosses out. 11x minus 10x is x. Drop down the plus 12. I'm running out of space. X times what is x? Positive 1. Multiply 1 to the entire factor and write it underneath. X times 1 is x. 1 times 2 is 2. Subtract what you got here. So minus sign, minus sign. 12 minus 2 is 10, which becomes my remainder. So what you do, since this is positive, is I'm going to put a plus sign in here. If it was negative, I'd make it minus, but plus 10 over the original factor, which is x plus 2. So my final answer is this mess right here. 2x to the fourth minus 4x to the third minus 7x squared plus 5x plus 1. And since my remainder was 10, plus 10 over my factor, x plus 2. Long division. Divide using synthetic division. I love synthetic division. Look at it. Oh my gosh. This is what you do. This is what synthetic division looks like. Don't know why it looks like that, but we have that weird little box on the top left and this weird little box on the right. So that's how you set it up. What goes inside this little box is the root of this factor. The root is whatever makes this factor equal to 0. So quick math would be x plus 4 equals 0, subtract 4, x equals negative 4. So let's throw negative 4 in here. What goes here are the coefficients to whatever it is that we're dividing our factor from. I said fractor. I did it on purpose. If you're missing something in between, you throw in a 0, but it looks like we're not. So you just have 6 for x to the 5th, then 21 for x to the 4th, then negative 14 for x to the 3rd, negative 8, 1 for x, and then negative 6. Drew that out perfectly. Synthetic division. Step number 1 is always drop down the first coefficient below the line. Then you take that number and multiply it to the root. So 6 times -4 is -24. Write it underneath the next coefficient. Take these two numbers, add them up. 21 plus -24 is -3. And now it's just repeat, repeat, repeat. -3 times -4 is +12. Add them up. -14 plus 12 is -2. Multiply. -2 times -4 is +8. Add them up. -8 plus 8 is 0. Multiply. 0 times -4 is 0. Add these up. You get 1. 1 times -4 is -4. Add these up and you get a remainder of -10. Now, what does this mean? Well, my final answer are the coefficients of whatever's left over. This is a remainder. My remainder is -10. Now, just like long division, you take your remainder and you put it over the factor that you use to divide this polynomial. So since this is -10, I'm going to have -10 over x plus 4. Now you go to the right and you attach variables starting at the degree of 0, which means 1 x to the 0, which is just 1, plus 0x, which means, 0x. I'll get rid of that, I guess, in a minute. Minus 2x squared minus 3x cubed positive 6x to the 4th. Now, writing this all out one last time and getting rid of this guy, I have a final answer of 6x to the 4th minus 3x cubed minus 2x squared plus 1 minus 10 over x plus 4. So this is synthetic division. I have a video on long division. Watch that. I prefer this because it's a little bit faster. It's a little bit cleaner. But I love both of them like they're my own children. If math was my own children, it would be the divisions. By the way, I do love my kids. Solve 2n squared minus n minus 4 equals 2. This is a quadratic. And in order to solve a quadratic, you really need to get 0 alone on one side. So the way we're going to do that is we're going to start out by subtracting 2 from both sides. There you have it. That gives us 2n squared minus n minus 6 equals 0. Now, this is probably factorable, but what I'm going to do is I'm going to use the old quadratic formula. Let me sing it for you. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Copyright goes to Nick Parrish. Now, I know this is x equals and I was given n, so I'm just going to pretend that that x is an n. But what I need to do is I need to label these guys up here. A, -1 is going to be b. Okay, -1, -6 is going to be c. We just throw stuff in. Watch out for double negatives. There's going to be probably quite a few of those. Negative b is going to be -1. So right away we have a double negative. Plus or minus, positive or negative, big square root of b squared is going to be -1 in parentheses squared minus 4 times a, which is 2, times c, which is -6. Let me scooch that over. Let me give myself a little bit more space. And then we have over 2a, which is going to be 2 times 2. All right, let's do some simplifying. -1 is regular 1. Positive or negative? All right, we've got -1 squared, which is 1, minus 4 times 2, which is -8, times negative 6 is going to be plus 48. How convenient is that? All over 2 times a, which is 4. So this gives us 1 plus or minus the square root of 49 over 4. This gives us 1 plus or minus 7 over 4. Now at this part, we are going to split this up into 2. One is going to be 1 plus 7 over 4, because it's positive or negative, and the other one is going to be 1 minus 7 over 4. 1 plus 7 over 4 is 8 over 4, which becomes 2. So one of my answers is going to be not x, but n equals 2. And the other one is going to be 1 minus 7, which is negative 6 over 4, which simplifies to negative 3 over 2. So when I have somewhat friendly answers like this, yeah, the original problem was factorable, but you know, what fun is that when we could just use the quadratic formula and sing? Solve 8a squared plus 6a equals negative 5. This is a quadratic, so the first thing I want to do is get the right side, or any side, equal to 0. So let's do that by adding 5 to everything. That gets me 8a squared plus 6a plus 5 equals 0. Is this factorable? I don't know. But let's do the quadratic formula because I love the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. One of my previous videos, I sing that. If you love a good song, look it up. Look it up. All right. Let's label U A, let's label U B, and let's label U C, and let's just plug stuff in. Negative B is going to be negative 6, plus or minus square root. B squared is going to be 6 squared minus 4. A is going to be 8. C is going to be 5. Scooch that over a little bit. Let's put it all over 2 times a, which is 2 times 8. All right, negative 6. Can handle that one. Plus or minus the square root. 6 squared is 36. Minus, let's do this kind of a little out of order. 4 times 5 is 20 times 8 is 180, 160, I mean. So minus 160 all over 16. Okay. That's going to equal negative 6 plus or minus 36 minus 164 is going to, oh, why did I write that out? (36 minus 164). And let's switch colors. Negative 6 plus or minus 36 minus 164 is negative 128. All over 16. Now, negative 128, okay, let's just move this over here, is the same exact thing as 64 times 2, which is the same thing as saying 8 times 8 times 2. So what we can do is we can simplify this square root. And if you notice, I have a negative under there. So we have imaginary numbers. So the first thing I'm going to do after I write out my negative 6, I'm going to leave myself a little bit of space. Is since negative 128 is the same thing as negative 8 times 8 times 2, I can bring out an 8. And since it's negative, I can bring out an I. What's left over is 2, and that's going to be all over 16. Now, that's an even number, that's an even number, that's an even number. So to go a little bit further, I can pull out a 2, which gives me negative 3 plus or minus 4i root 2 over 2 times 8 cross out the 2's, and I can finally say, let's not use x, it's a. I can finally say a equals negative 3 plus or minus 4i root 2 all over 8. Now that's pretty much it. I can be done if I want to be. I know a lot of teachers might have you split this up and go a little bit further where you would simplify that, but I'm not going to go any further. I'm out of space, and that's an answer that's good enough for me. So quadratic formula with a little bit of imaginary numbers. Fun, fun. Find the zeros of f of x equals x cubed plus 8. Now, find the zeros means, let's just set this up like this. 0 equals x cubed plus 8. Now, x cubed plus 8 should look familiar to you. X cubed is a cube. 8 is also a cubed. It's 2 cubed. So what we have is a sum of cubes. Similar to difference of squares, there's sum of cubes, difference of cubes. There's no such thing as sum of squares, but there is a sum of cubes. And it looks a little something like this. Let's just say you have a cubed plus b cubed. That's going to be the same thing as a plus b times the quantity a squared minus ab plus b squared. Now, in this case, what's a, what's b? Well, if we're comparing a cubed to x cubed, then a is x. And if we're carrying b cubed to 8, which is 2 cubed, then b is 2. So let's fill this in using the letters. A is now x, okay? B is now 2. So a squared is x squared minus, now let's be a little clever here. X times 2 is going to be 2x. And b squared is going to be 4. Now, let's not forget the original problem. This guy, x cubed plus 8, is now what's here in green, and originally it's equal to 0. So I'm not sure if I can factor this out, and I'm not even going to try to, but if my job is to find the zeros, I have one of them. And one of my zeros is going to be x equals negative 2, because I'm using the zero product property. Now, what I also know is this chunk right here is equal to 0. And we could probably use the quadratic formula to do it. So, x equals negative b plus or minus square root b squared minus 4ac all over 2a. More singing. So let's plug stuff in. A is an invisible 1. B is negative 2, C is 4. So x equals negative 2, positive 2, plus or minus the square root of b squared, which is going to be negative 2 squared, so 4, minus 4 times a, 1, times c, 16, all over 2a, which is 2 times 1, which is 2. This ends up being 2 plus or minus the square root of negative 12 over 2. Now, negative 12, or regular 12, is 4 times 3, which means 2 times 2 times 3. So if I wanted to, I can take that and turn that into the square root of negative 2 times 2 times 3, which means we can bring out a 2. Not only that, we can bring out an I, and we're left over with this square root of 3, all of this being over 2. Now I have a 2 and a 2 and a 2, so let's deal with that. 2, let's pull it out, leaves me with 1 plus or minus I root 3, close it, all over 2. The 2's cancel, and my other possible answers are going to be x equals 1 plus or minus I root 3, which goes along with negative 2. Those are my 3 answers. So one was simple, one was quadratic formula. All of this means I have 3 answers, which makes sense. According to the fundamental theorem of algebra, I'm going to have 3 answers here. 2 of them are complex, 1 of them is real. Fun, 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 fun. All right, we need to factor 28n to the fourth plus 16n to the third minus 80n squared. You know from Algebra 2 that factor could be so many things. It could be pulling a greatest common factor out. It could be like dealing with a quadratic. In this case, I'm going to start out by knowing that these are all even, and I can definitely bring out a 4. I can bring out an n squared, so let's start out with that. 4n squared. When I bring that out, I am left with 7n squared plus 4n minus 20, and that's it. I don't know why that took me so long, but it took me so long. Now, when I'm done pulling a greatest common factor out, I'm left with what looks like is a quadratic, because it is, and I should be able to look at this and ask myself, does this factor any more? Okay, can I write this guy right here as this? Well, let's try a few. In order for me to do this, I have to have a 7n and an n. One of these has to be positive, one of these has to be negative. So let me think of two numbers that multiplies out to 20. So how about 10 and 2? If I were to make you a positive 10, and if I were to make you a negative 2, and do a little bit of math, I'm not going to get that plus 4. That didn't work. Okay, so let's try this. Let's try, you know what? I think I figured it out by guessing and testing. If I made you a positive 2 and made you a negative 10, then when I FOIL these out, I have 7n times n, which is 7n squared, 7n times 2, which is 14n, minus 10n, I get my 4n, and then I have my minus 20. So if you struggle with a problem like we just did there, this is called solving quadratic equations with a leading coefficient. I have videos on those, and I'm not going to spend a ton of time doing that here, but I have a pretty significant video on how to solve quadratic equations when you have a leading exponent. Make sure you look that up because that's the problem here. Okay, but we're done. We factored. We don't have to solve. We don't have to do any more. That's it. Evaluate f of x at k. All right. This is kind of a bizarre problem. This is supposed to lead us into the fundamental theorem of algebra. And right now, all it's asking is for me to find f of 1. Okay? I don't know why it's written out this way. Sometimes it'll say x equals 1, but this is not something to overthink. You just plug in 1 for every x. So 1 to the 5th minus 4 times 1 to the 4th minus 5 times 1 squared minus 5. Okay, 1 times itself a bunch of times is just going to be 1, minus 4 times itself a bunch of times, 1 times itself a bunch of times is 1, 5 times another 1, and then 5 is all on its own. You become 5, you become 4, you become 5, that's negative. You become 5, that's negative. 5 minus 4 is 1. 1 minus 5 is negative 4 minus 5 again is negative 9. So f of 1 is negative 9. And that's it. Find the remainder when f of x is divided by x minus k. All right, so this is all about the remainder theorem, which says if I have a factor x minus k, I could take that k, which in this case is negative 2, and do a little bit of division and get a remainder for a polynomial. So what I'm going to do, since it's a whole lot faster, is I'm going to do synthetic division. All right, I have a video purely on synthetic division on this channel. Give it a watch. But this is more remainder theorem-y, so I'm going to treat it more remainder theorem-y, which I'm pretty sure theorem-y is a character in Lord of the Rings. Just kidding. That's not the case. I've got let me see, 5, and then 5 again, and then -7, and then 7, and then 5, and then -4, and then -1, and I'm expecting my remainder to live right down here, whatever that might be. If you're missing like an x something, like if I was missing an x to the third, I would make sure I use 0, but I wasn't missing anything. Everything's already in order. God is good. Step number 1, drop down the 5. Okay, now multiply these two together and write it underneath the next coefficient. So 5 times -2 is -10. Write it under the 5 and then repeat. 5 plus -10 is -5. -5 times -2 is +10. Add these. -7 plus 10 is 3. 3 times -2 is -6. 7 plus -6 is 1. 1 times -2 is -2. 5 plus -2 is 3. 3 times -2 is -6. -4 plus -6 is -10. -10 times -2 is 20. -1 plus 20 is 19. My remainder is 19. Now, when I did synthetic division, I was asked to actually divide, and so I was able to use this and turn this into a whole other polynomial, with that being part of my remainder and part of my answer. But that's not what we're doing here. This is just remainder theorem, and all I have to do is just that, find the remainder, and it's 19. Great. Write a polynomial with integer coefficients using these given zeros. All right, I'm going to approach this kind of like in a weird step-by-step basis. Thing number 1, I'm given 2 roots. That doesn't mean anything. I actually have 3, and you might be thinking, no, there's 2 there. There's a little thing called the conjugate rule that says if you have something in this form as a root, you must also have something in this form as a root. And you might be thinking, well, we don't have anything that looks like a plus bi. Yes, we do. That's a plus bi because it's a complex number that can be written out as 0 plus 2i, which means 0 minus 2i also has to be an answer. So I have to throw -2i in there. Okay, so that's thing number 1 that you have to be careful of. The problem is kind of incomplete, and you have to fill in the blanks yourself. Those are my 3 roots. Now, another thing that I want to look at is reminding ourselves what zero product property says. If I have something that looks like this, and I'm just picking random numbers, if I have something that looks like that, I know that my answers are going to be x, why did I pick 0? Let's make it a 10. X equals 5, and x also equals -10. So if I get the parentheses, then I know the roots. Well, now I have the roots, so I should be able to do this, throw opposite symbols in front of these, and throw them in the parentheses to get a similar idea. So what I'm going to do is I'm going to write out x minus 4/5, x minus 2i, and x plus 2i. Now what I have to do is I have to simplify this out. So I'm going to use my eyes over here, knowing very well that things are probably going to go away, things will disappear, but I'm going to multiply this out. So I haven't touched x minus 4/5 yet. Not yet. I will. But if I FOIL this out, wonderful things are going to happen. X times x is x squared. X times 2i is 2ix. -2 times x is -2ix. How about that? -2i plus 2i, or times +2i rather, is going to be -4i squared. Now, before you're like, oh, this is a nightmare. No, it's not. These guys go away. And what's also nicer is I squared. Remember, I squared is the same as negative 1. So negative 4I squared is the same as positive 4 because it's negative 4 times negative 1. So let me write this out as x equals 4, not x equals, x minus 4/5 and x squared plus 4. Now let's factor, that's supposed to be a parentheses. Let's factor this out. X times x squared is x cubed. X times 4 is 4x. Negative 4/5 x is negative 4/5 x squared is negative 4/5 x squared. And negative 4/5 times 4 is negative 16/5. Now, before I call it a day, remember, this is all equal to 0. So this is all equal to 0. Before I call it a day, I'm supposed to have integer coefficients. So what I'm allowed to do is I'm allowed to multiply both sides by 5. Why am I doing that? To make these fractions no longer fractions. So by doing that, I now have a polynomial where I can have 5x cubed. Let's put it in order. 5 times negative 4/5 is going to be negative 4x squared. Okay, I'm doing this one. Plus 20x minus 16. That is a polynomial that when set equal to 0 gives me zeros of 4/5 and 2i. And oh yeah, by the way, negative 2i. State the number of complex zeros, the possible number of real and imaginary zeros, and the possible rational zeros for each function or for this function right here. What a mess, what a mess, what a mess, what a mess. Well, let's start out with complex zeros first. What is a complex zero? Well, a complex number is a number in this form right here. Now, if I were to pretend that that b is gone, then my complex number is real. If I were to pretend that that a is gone, then my complex number is imaginary. So complex numbers could be real or it could be imaginary. According to the fundamental theorem of algebra, whatever your leading term's degree is the amount of complex zeros you're going to have. So in this case, we are going to have 5 complex zeros because this is a 5th degree polynomial. So that's part 1. Part 2 says if I'm going to find, let's actually jump to imaginary zeros before we do real. Part 2 says if I were to have an imaginary number, like a plus bi, I have to have its conjugate also floating around as my answer as well. So imaginary zeros, if you're going to have one, you must have the other. So I could have no imaginary zeros. I could have 2 imaginary zeros. I could have 4 imaginary zeros. So it's basically even numbers all the way up until you hit complex, but you're not allowed to go beyond it. So since my highest degree is 5, I start out with 4 and work my way down. Now what that means is since I could have 5 real numbers, I could also have 3 real numbers, and I could also have 1 real number. Okay, so whenever you're being asked to find your your real numbers, you start with the odds and work your way down from there. Now on to the nightmare scenario, the rational root theorem. Okay, the rational root theorem has me listing out every single possible root that is rational that I could have and is an absolute god-awful nightmare. Okay, but this is what we do. We already have this written in order. I'm going to call you Q. It'll be nicer if I had a pen. I'm going to call you Q, and I'm going to call you P. Now, my rational roots are all the numbers in the form plus or minus P over Q, where P are all the possible factors of P, and Q are all the possible factors of Q. So what are my factors of P? 9, 3, and 1. What are all my factors of Q? 15, 5, 3, and 1. Now what I'm going to do is I'm going to list out all 12 possible numbers in the form P over Q. Technically, it's 24 if I throw the plus or minus in there. So let's go in order. Plus or minus 9 over 15, 9 over 5, 9 over 3. We'll simplify these in a little bit. I'm going to forget my pluses or minuses. Don't want to do that. And 9 over 1. Now, I'm expecting repeats to take place. Okay, so if you're looking at this and saying, will we have 12 separate ones? Nope. When things simplify, we will have repeats and we'll get rid of the repeats. Okay, now let's do 3 over 15 plus or minus 3 over 15 plus or minus 3 over 5 plus or minus 3 over 3 plus or minus 3 over 1. Now let's do plus or minus 1 over 15 plus or minus 1 over 5 plus or minus 1 over 3 plus or minus 1 over 1, running out of space. All right, so let's write these all out and get rid of the repeats. Let's simplify while we're at it. Plus or minus 9 over 15 can be written out as 3/5. So we're done with U. Plus or minus 9 over 5 is simplified as much as it can be. Plus or minus 9 over 3 is 3. Plus or minus 9 over 1 is 9. Plus or minus 3/15 is 1/5. Plus or minus 3 over 5, I did already. Plus or minus 3 over 3 is 1. Plus or minus 3 over 1, I did already. Plus or minus 1 over 15. Plus or minus 1/5, I did already. Plus or minus 1/3. And plus or minus 1, I did already. So these are my options, all of them in all of their glory. Do I have to put them in order? Nah, I'm not going to, but I did it. That's the rational root theorem. I sprinkled in some fundamental theorem of algebra in here. A lot going on in this one little problem, but we did it, and I'm proud of you. Identify the points of discontinuity, the holes, the intercepts, and the horizontal asymptote, and the domain. Goodness gracious me. All right, well, lots to answer, so I have myself a quadratic over a quadratic, and the first thing I want to do is factor the quadratics. So I'm going to do just that. Two numbers that add up to -1, multiply out to -6 are going to be -3 and 2. So the numerator factors out to that. The denominator, two numbers that add up to -2 and multiply out to -8 are -4 and 2. Oh, look, 2 2s. Just like at a ballet recital. What am I doing first? Point of discontinuity. A point of discontinuity are the x values that if you were to plug into this equation, the whole thing, all right, would make it undefined. In other words, what numbers, if I were to plug into the bottom here, would give me a undefined equation? Well, if I were to plug in 4, and if I were to plug in -2, 4 would make this 4 minus 4, which makes that 0, which makes the whole thing 0, discontinuous. And if I were to plug in -2, same exact thing would happen. That is the zero product property in action. There's my points of discontinuity. A hole exists when you have a point of discontinuity existing in a parentheses. That's the exact same thing as you have there. So in this case, since I have an x plus 2 on the bottom and an x plus 2 on the top, my hole exists at -2. Okay, which means like if I were to graph this, there's not an asymptote happening. You just have a break in the graph. That's what a hole means. An intercept. Let's start out with the easy one, the y-intercept. And remember, you find the y-intercept by substituting 0 into your equation. So simply put, if I were to take f of 0 and plug in 0 for x, I would get 0 squared, which is 0, minus 0 minus 6, over 0 squared, which is 0 minus 2 times 0, which is 0 minus 8. And my y-intercept simplifies to -6 over -8, which is positive 3/4. That's my y-intercept. Now, the x-intercept is a little more involved. Okay, the x-intercept is what if I set my y, or my f of x, equal to 0. Okay, so let me not use red. I just used red. What color haven't I used? Black. X-intercept, I'm going to set my f of x equal to 0. So 0 equals x squared minus x minus 6 over x squared minus 2x minus 8. Now, what I'm going to do is I'm going to multiply both sides by this guy right here, which eliminates that entire thing. So now I'm left with x squared minus x minus 6. Let's not forget that if I wanted to use zero product property and factor this guy out, x squared minus x minus 6 is x minus 3 and x plus 2, which means my x-intercept is going to be positive 3 and -2. Oh, but wait. X can't be -2 because it's discontinuous there. So my only x-intercept is going to happen at 3. So again, my x-intercept looks like it should appear at 2 places, but it's not allowed to be -2 because -2 is where my line is discontinuous. Last but not least, let's get a nice little orange color going on here. Last but not least, my domain. Let's get rid of the color palette. My domain, when graphing these things, is going to be everything but where this is discontinuous. So what I will say is my domain is going to be all real numbers, but x cannot equal 4 and x cannot equal -2. Where did I get 4 and -2 from? Well, that's where my graph was discontinuous. So my domain says I'm allowed to plug in all real numbers except for 4 and -2. So lots going on there. But there you have it. I think I covered everything. Solve a big fraction with a polynomial minus another fraction with a polynomial equals another fraction. Look at that, with a polynomial. There's a little rule that says, and this is how we're going to start off. If you have a over, I don't know, smiley face. This is me drawing a smiley face. And you have b equals a smiley face, that at the end of the day, the smiley faces cancel each other out and you have a equals b. Now, why am I bringing that up for a problem like this? Well, these guys are the same. If I can find a way to make this guy look like this guy and combine these fractions, then I will have a fraction equaling a fraction where the denominators are the same and therefore the numerators will be the same. So this is what I'm going to do. In order to make these fractions have all the same denominator, I'm going to factor that guy, which also factors that guy, and hope that n plus 1 is one of the factors. I have a feeling it will be. So I have 4 over n plus 1. Okay? I'll leave that right there. Minus 1 over n squared plus 7n plus 6. I need to come up with two numbers that add up to 7 and multiply out to 6. Well, 1 and 6 should do it. So there's my n plus 1, and there's my n plus 6. That's going to be equal to 3 over the same exact thing, n plus 1 plus n plus 6. My goal here is to have the same exact denominator. In order for me to turn this fraction into a denominator with n plus 1 and n plus 6, let me throw parentheses around them even though it's not necessary. And I'm going to multiply the numerator and the denominator by n plus 6. What that'll allow me is to have the same exact denominator all the way throughout. Okay? So now I can do this. If I were to distribute 4 to n plus 6 in parentheses, that gives me 4n. 4 times 6 is 24. And now that these are the same denominator, I can combine the denominators, giving me this guy, and minus 1 comes along for the ride. That's going to equal 3 over n plus 1 in parentheses, n plus 6. While I'm here, what I'm going to quick do is I'm going to quick erase 24 minus 1 and make that 23, just so that I don't have to rewrite so much. And since these two denominators are the same, okay, I don't need them anymore. So that leaves me with 4n plus 23 equals 3. My next step is to subtract 23 from both sides. Minus 23, cross you out. And let me write it up here where I have a little bit more space. 4n equals negative 20. Divide both sides by 5. 4. This is me just accidentally thinking ahead, because when I do that, I get negative 5. And n equals negative 5. That's my guy. That's my solution. And I'm done. Solve x squared minus 4x minus 32 has got to be greater than 0. Okay, this is an inequality. Now, I don't know exactly what this picture is going to look like, but let's just take some arbitrary thing. I know this opens upward. And let's just say that my picture looks like this. Okay, let's just make believe. Who knows what this looks like? What I care about are the x values that are going to make my value positive, which means I only care about everything from here on over, and I only care about everything from here on over, because whatever of these x values that I plug in is going to give me a positive y value. I know I said y, I probably shouldn't have said y. It's just going to give me a positive value in general. I don't want any of these. So what I'm going to do is I'm going to find out what these are. And I can do that by factoring things out and using the zero product property, because I care about a zero. So step number 1, let me get rid of you, let me get rid of you, let me get rid of you, let me get rid of you. Step number 1 is I'm going to factor this out. That should be pretty simple. Two numbers that add up to negative 4 multiply out to negative 32. One's going to be positive, one's going to be negative. Looks like 8 and 4 will do it. The 8's got to be negative, because negative 8 plus 4 adds up to negative 4, not the other way around. So now that I have this, I have a slightly better picture where I know my zeros are going to be negative 4. And I'm going to say that. My zeros are going to be negative 4 using the zero product property. It's going to be the opposite of that, and it's going to be positive 8. So now that I have a little bit more clarity, I can draw myself a slightly better picture, a picture that looks like this, where this guy right here is negative 4, this guy right here is 8, and I only care about these parts right here. Now, I knew that my picture would look like this. So technically I have my answer, but let's just say I didn't know. Let's just say I didn't know what the picture looks like. This is a backup plan. I'm going to create what's called a sign graph. Now, this is very calculus-y. you're going to do this a lot in calculus. So I'm doing this too to prepare you because this is a pre-calc class and its job is to prepare you for calculus. Let's just say I didn't know what the picture looked like. Okay, what I want to do is I want to pick numbers that are not -4 and are not 8 and live in these three areas that I care about. I care about everything less than -4. I care about everything between -4 and 8. And I care about everything greater than 8. And what I'm going to do is I'm going to plug it into the original problem and see if by plugging it in gives me a positive or negative value. If it's positive, that means I want it. If it's negative, that means I don't. So I'm going to pick three numbers that live in these three areas. So let me pick -10, let me pick 0, and let me pick +10. Why did I pick those numbers? Because they're easy to deal with. What I'm going to do is I'm going to pick -10, I'm going to pick 0, and I'm going to pick +10 and see if it gives me a positive or a negative value when I plug it in. So I'll say f of, even though there's no f in the original problem. I already said why. Why not commit to it? If I plug in -10, I'm going to get 100 plus 40 minus 32. Doing a little mental math, but without doing too much, 100 plus 40 minus 32 is definitely going to be positive. So as we can see from the picture that I drew, this gives me exactly what I want. This is positive. I'm happy. If I plug in 0, I get 0 minus 32. That's definitely going to be negative. Okay, so I don't want this interval. And if I plug in 10, I get 100 minus 40 minus 32, which is 38 or something like that, or 28 or something like that. It doesn't really matter. It's positive. So this area checks out. So again, I made believe just for a few seconds that I didn't know what the picture looks like. Even though I know this opens upward, I'm still make-believing because I love make-believing. It's fun. All right. And I found out that by plugging in specific numbers and by finding out my zeros, I was able to determine if those numbers would definitely be positive, definitely be negative, and definitely positive. And since these were greater than, the original problem is greater than, I only want the positive ones. So the positive x values that I care about, the x's that I definitely want, are everything less than -4 and everything greater than 8. Okay, because everything in between -4 and 8 is negative. Don't want that. Why doesn't it equal -4? Why doesn't it equal 8? Well, if I plug in -4, I get 0, which is neither positive nor negative. So this is my answer. Those are all the possible x values that, when plugged into the original problem, give me something greater than 0. Again, this is very calculus-y, so understand this process. This will not go away anytime soon. Ooh, we've got ourselves solving rational inequalities. The first thing you're going to want to do is remove everything from the right side, move it to the left. So let's do that. I have -3 over x plus 7, and I'm going to wave my hands a little bit. I would add 4 over x plus 8 to both sides, so that will look like that, and now I have that. What I'm actually going to do is I'm going to scooch that over a little bit because you'll see what happens next. And I'm going to turn that -3 into its own -3. So let's clean that up. Let's scooch that over because my next step is to combine these fractions. Now, when you combine fractions of any kind through addition, you need a greatest common denominator, or maybe a least common denominator. In this case, the least common denominator is going to be x plus 7, x plus 8. So I'm going to multiply u by x plus 7 over x plus 7, and I'm going to multiply u by x plus 8 over x plus 8, like so. All right. Now I'm going to use distributive property. That gets me -3x minus 24. I'm going to use distributive property again. That gets me 4x, how convenient, plus 28. And now all of this is going to be over x plus 8 times x plus 7, and it's still less than or equal to x, or 0. When I combine all of these, negative 3x and 4x combine to make x, negative 24 and 28 combine to make 4, and I have x plus 4 over x plus 8 times x plus 7. Now I have three factory-looking things here, and in fact, I'm going to put that in parentheses to really emphasize that point. What I need to do is very similar to when I was having polynomial inequalities. I'm going to create what's called a sign graph, S-I-G-N. And in this case, I care about when things happen at what would create zeros. So I care about things happening at negative 4. I care about things happening at negative 7. So I'm all out of order. So technically negative 4 would happen here. I care about things happening at negative 7. And I care about things happening at negative 8. Okay, so I need to pick numbers that are not equal to these numbers but live in specific intervals. So for example, I need to pick numbers like negative 10. This is going to be a pain in the butt. Negative 7.5. How about negative regular 5 and 0? And I need to see which of these numbers are going to be less than or equal to 0. So I can actually use this equation right here. If I plug in negative 10, if I plug in negative 7.5, if I plug in negative 5, and if I plug in 0. Okay, let's see what happens. I'm going to try to do most of these mentally so as not to really kill my brain here. But this will be negative 10 plus 4, which is going to be negative 6. Negative 10 plus 8 is going to be negative 2. Negative 10 plus 7 is going to be negative 3. Okay, negative over a negative times a negative is going to be negative over a positive, which makes this negative. So this makes me happy. I want this. 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 Now let's plug in negative 7.5. If I plug in negative 7.5 on the top, that gets me a negative. Let's do it this way because I really don't care about what numbers I get. I care about what kind of numbers I get. So I get a negative if I plug in negative 7.5. If I plug in negative 7.5 here, I get a positive. And if I plug in negative 7.5 here, I get a negative. So this negative over negative is going to be positive, which means I don't want the numbers between negative 8 and negative 7. If I plug in negative 5, running out of space, if I plug in negative 5 plus 4 is going to be a negative number. Negative 5 plus 8 is going to be a positive number. And negative 5 plus 7 is going to be a positive number. So negative over positive times positive is negative. So you're good. And if I were to plug in a number like 0, I would get positive over positive times positive. Positives all around. So that's positive. So that's no good. Now, before I create my intervals, before I say what's what, okay, one of the things that I also have to keep in mind is numbers like 8 and numbers like not 8, but negative 8 and numbers like negative 7 are not allowed. Why? Because that would make this undefined. So the numbers that I want are everything less than negative 8, but I'm not allowed to include negative 8. So x is less than negative 8. I also care about the numbers between negative 7 and negative 4. So I can say that negative 7, I'm not allowed to include it, is less than x, which is less than or equal to negative 4. That's my guy. If you have a teacher that wants you to write it out in this type of notation, like the union notation, you could write it out as negative infinity goes to negative 8 with the parentheses, and, union means and, negative 7 to negative 4 with a bracket because we are allowed to include -4. There's nothing here that says we can't plug in -4. If I were to plug in -4, I get 0, and I'm allowed to get 0, and this won't be undefined. So that's my guy right there. Ooh, it's a doozy. But that does it for this section.